All right, class, with this video, we're going to begin working with solving equations with variables on both sides. So I want to begin by doing just a little bit of review. We see this problem right here, and this is something that you've been doing for a while. We have a single variable in the entire equation, and we just want to solve for x. And so I bet many of you can look at this and see that x equals 4. You can see that you know the whole equation wants to equal 8. That means everything on the left-hand side wants to equal 8. In order to do that, you need x to equal 4. Well, algebraically, we know that we subtract 4 from both sides, which equals 4. So we see that x equals 4. Hopefully that is just a simple, very quick review for you. What we have now is we want to put a variable on both sides of the equation. The thing is, though, nothing changes. We're going to use the exact same process, the exact same rules. And so what I like to do is I like to put it all on one line. Now, you can divide this up and do several lines, as we've talked about in class. But here, we're going to get all the variables on one side. So in this case, I have a positive x. So I'm going to need to subtract x from this side to get that to 0. But what I do to one side, I have to do to the other. So I subtract x from both sides. That gives me 2x minus x, which just gives me x. But if I'm going to put the variables on one side, then I need the integers on the other. So that's a positive 3. I'm going to subtract 3 from both sides, and that goes to 0. So we could write that as x plus 0. I'm not saying you need to do that, but let's do a space holder for now. 5 minus 3 is 2. So if we reduce this, that's x equals 2. Now we can check this by substituting 2 in for everywhere we see an x. And so what if we were to do 2 times 2? See, I have an x here, and so anywhere I see an x, I'm saying that x must equal 2. So we're going to plug in the 2 for x. 2 plus 3 equals 2 plus 5. Well, 2 times 2 is 4. 4 plus 3 is 7. Equals 2 plus 5 equals 7. And so it checks. And what I'm looking for right here is a true statement. If I were to get something like 7 equals 8, then I'm incorrect. That's not a correct answer. It could also mean that the equation has no solution, but we'll talk about that in another video. But right now, if I solve everything for x and I get an answer x equals 2, I substitute that back into the original equation. Everywhere I see an x, I replace it with the 2. And what I'm looking for is one side must equal the other. In this case, 7 equals 7, and that's a true statement. 7 does, in fact, equal 7. Let's look at another example. Same process. I'm going to move my variables to the left-hand side. I'm going to move my integer to the right-hand side. And so I'm going to subtract x from both sides. That's going to give me 2x, and the x's would go to 0. I'm going to add 4 to both sides in this case. So that goes to 0, and 4 plus 4 equals 8. And so there I'm going to have 2x equals 8. Well, I'm not solving for 2x, I'm solving for x. So I want to get x by itself. 2 divided by 2 is 1. So that leaves me with an x by itself. 8 divided by 2 is 4. Because remember, what you do to one side, you have to do to the other. Well, why don't we check it? So let's substitute 4 in for everywhere I see an x. So that's going to be 3 times 4 minus 4 is equal to 4 plus 4. So I want to see, does the left-hand side equal 8? 3 times 4 is 12. 12 minus 4 is, in fact, 8. So I can rest assured that that answer is correct. All right, let's look at one more example. Why don't we try some fractions? Now, as I say in class, fractions, they're our friends. But sometimes we like to love friends from a distance, right? And so I want to get rid of the fractions as quickly as I can. A great way to do that is when we see that both of these, this has a 3 as a denominator and this has a 6, so they're not common denominators. So I can't add 1/6x to both sides. Or I can, but as soon as I do it, I'm going to have to convert one of those to have a common denominator. There's another way that I like to do that helps. what if I put parentheses, two sets of parentheses around both sides of this equation? And I'm looking for the least common multiple of the denominators. In this case, that would be 6. 3 goes into 6 evenly. 6, of course, goes into itself. So I can multiply each side by the least common multiple. And so 6 times 2 is 12. So that's going to be 12 over 3x minus 6. Now remember, you have to distribute throughout the parentheses. Multiply the 6 or distribute the 6 throughout. 6 times 9 is 54 minus 6 over 6x. Now you can hopefully see what's beginning to happen here. 12 divided by 3 is 4, so that's 4x minus 6 is equal to 54 minus x. So in one quick step, I have removed the fractions entirely, and I'm left with a pretty basic equation at this point. Let's change our colors again. Let's go ahead, and we're going to move the variables to the left-hand side, and you will probably always see me do that. It's just a pattern that I have. And I'm going to add 6 to both sides to get my integer to the right-hand side. So that's 5x equals 60. Why don't we go up here, give us a little more room. 5x equals 60. But again, I'm not solving for 5x, I'm solving for x. So I'm going to divide both sides by 5 so that the 5 divided by 5 is 1. That leaves me with an x by itself. And 60 divided by 5 is 12. All right, let's check it. Always check your work. And so let's plug it into the original equation, 2/3 times 12. I'm substituting, right? I'm substituting anywhere I see a 12 because 12 equals x. They're the same thing. Anywhere I see an x in the original problem, I can replace it with a 12. Make sure you use your parentheses. Parentheses, very important. 9 minus 1/6 times 12. All right, so a couple of ways you could see this problem. 12 times 2 is 24, divided by 3 is 8. You could also say 12 divided by 3 is 4. 4 times 2 is 8. Either way, 8 minus 1 is 7. 12 divided by 6 is 2. And 9 minus 2 is 7. And so I know that I am correct. This equation up here, the 2/3 x minus 1 equals 9 minus 1/6 x, is true, meaning when I say it's true that the equal sign, they actually do equal one another. This would be like if I let this side be A and this side be B, I can say that A does in fact equal B when x equals 12. There's one solution to this problem, not 2, not 10, there is one, and it's 12. When x equals 12, 2/3 x minus 1 is equivalent to 9 minus 1/6 x. All right, guys, I hope this helps. I'll do some more videos on these as well.